Okay, welcome to the second part of looking at the applications of trigonometric relations. What we're going to look at is the last two, which are a little bit more conceptually difficult because they require several steps. Looking at the first one, we have 2 points, P and Q, and they lie 400 meters apart from each other on opposite sides of a communication tower. So we have two sides, they are 240 meters apart. And in the middle, there's a communications tower. The angles of elevation to the top of the tower from P and Q are 50 degrees and 45 degrees respectively. What we want to do is calculate the height of the tower. So what I'm going to do first is draw this out. So we have 2 points. We got P here and we have Q over here. There is a line between them that connects them. Okay. And this is 240 meters apart from each other. We have a communications tower right in the middle. We don't know if it's straight in the middle. I'm going to draw it slightly off because it doesn't tell us. So my assumption is that it is not in the middle, or else they would be looking at it from the exact same angle. So from P to the tower is looking up with an angle of elevation of 50 degrees. So from this point to the top of the tower, that is 50 degrees. From the other side, from Q to the tower, it creates a line that is 45 degrees. What we want to find out is this height. We don't know what it is. So conceptually right now, we don't have enough information to create a notion really of any way to figure out the tower. But there are ways to do it. We need to kind of look at this a little bit. So we don't know how to get this middle. This is something that's not necessarily known to us very well. We don't have a complete pair, so we can't use sine yet. We don't have a squished angle either. How this is going to work, our step one is to first find this angle. If we find this angle, we'll have a complete pair of angle and side. What that's going to enable us to do is it's enable us to find one of these two sides. I'm going to find out what side P is, but you could go and also find out what side Q is. Either way would work. Once you find out what one of these sides is, what you can notice is that this line in the middle creates two separate right angle triangles. If you look here, this one's one right angle and this is also a right angle. So at that point, once we have a side here, we can go ahead and use primary trigonometric ratios to find this height. So let's start off by finding what the tower's angle is. I'm going to call that T. So angle T is equal to 180 minus angle P minus angle Q. 180 minus 50 minus 45 is going to give us an angle of 85. So our tower's angle is 85. So this guy right here, that is 85. Now what you're going to notice is we have a complete pair. We have an angle and we have a side. So we can find out either this side or this side. What I'm going to do is find out this side. So I'm going to find out what length P is. So what we're going to do is create a sine law equation. So P over, I'm just going to state what I am doing, find side P. So P over sine P equals T over sine T. So our P in this case, we don't know what it is, but our sine P is 50. Our T is at 240 meters, and our T's angle is 85. What we want to do at this point is get sine P away, so we multiply it by sine 50 on both sides. These cancel each other out, and we're left with P equals sine 50 times by 240 all over sine 85. If you put that in your calculator, you're going to get a P of 184.55. I'm keeping 2 decimal places because I want to keep it somewhat accurate. So our last step, like I said, is we now have what this side equals. I'm going to write that in. That side is 184.55. What you'll notice here is we now have a hypotenuse of this right angled triangle. This is the opposite side of this angle. Because we have the opposite side, what we can do now is find out what that tower height is. So that's what we're going to do next. We're going to find that tower height. Okay. So find tower height. And because we have an opposite and a hypotenuse, we're going to use sine. So sine theta equals opposite over hypotenuse. The opposite is the tower's height. So sine 45, x, don't know what the opposite is, over 184.55. We're going to multiply the 184.55 out to get x by itself. So we get 184.55 times by sine 45 equals x. And x is going to equal 130 meters. So therefore, the height of the tower is 130 meters. So this was kind of a complicated step. We first had to go find the last angle to get a full pair. We then found what one of these lengths is. Again, I chose to go find P. You could have gone and found Q, and it would have been the same same sine ratio here to find the height of the tower. Okay, let's look at the next one. We have a bicycle race where cyclists set out from point A, which is right over here, and follow a circuit. So we get 30, 40, 40, and whatever this guy is here. A and B and DC are parallel lines. One clever cyclist kept track of the lengths of the first 3 legs and, nice enough, found out the angle of the first turn, shown in this diagram on the right. What it wants us to find is the length of the last leg of the race. What I'm going to draw out here is a little bit of an idea of what's going to happen when we're going to calculate this. So like with the last one, I'm going to draw a line to create a boundary which we can have information to deal with. A diagram like this is really 2 triangles shoved together. So what I can do right here is draw a line between the 2, and you'll notice that on one side I have 1 triangle, and on the other side I have another triangle. Seeing this, what you can notice is that we have a smushed angle between two sides here. What we can then do is find out what this length is. Once we find out what this length is, we will have a complete side and angle combination. What that's going to allow us to do is find out what this angle equals to. And because of the Z rule, we will then be able to find out what this angle equals to. At that point, we will have another squished angle. We'll have a number here for length as well as a length here. And then we'll have an angle here, which will then enable us to go and find out what this side length is. And that's what we're going to do. So the first thing we're going to do is find out what the AC length is. That's our first thing. We're going to find AC length. And how we're going to do that is by using the cosine law. And the reason we can use the cosine law, like I said earlier, is because we have this squished angle. So I'm going to call that side B. So B squared equals A squared plus C squared minus 2 AC cos B. What this is going to look like is 40 squared plus 30 squared minus 2 times 40 times 30 times cosine 72. And if we go and put that all in the calculator, square root it, we're going to get a length of 141.9 kilometers. So that length over here is 41.9 K. So what we want to do next is, because we have this full circuit here, we can go and find the angle A. So this angle right here. That angle, I'm going to call theta, will be the exact same as this angle here. Again, the reason why is these two are parallel. Using the Z rule, these will be the same. And if you notice, we now would have an angle that is squished. So step 2, we're going to find theta. And how we're going to do that is by using the sine rule. So sine theta over AB, sorry, not AB, BC, opposite of this angle is this side right here, is equal to sine B, this is angle B, over side B. So what we're going to do is fill everything in. We get sine theta over 40 kilometers. That's that side length. We'll sine 72 over 41.9. At this point, we want to multiply out the 40 on both sides. These cancel each other out. And we're left with sine theta equals 40 times 72, sine 72 over 41.9. Theta equals the sine inverse of these lovely numbers. And if we put that in our calculator, theta rounded to the degree is 65. So we have 65 degrees here and 65 degrees here. What you'll now notice is that we have a side length here, a side length here, and a lovely squished degree, a lovely squished angle. That is a perfect recipe for a cosine law to go and find out what AD equals to. So that's our last point, last step. So step 3 is to find AD. And we're going to use cosine law to do that. So AD squared is equal to, we already called the other one B squared, and we'll call this side right here, let's go with C squared. Actually A squared minus 2AB cosine theta. We're going to continue using theta because that's why I called it earlier. So we put in what we know. Our B is the 41.9 squared. Our A is the 40 squared minus 2 times by 41.9 times by 40 times by cos 65. If we put that into our calculator and square root it, we're going to get AD is equal to 44 kilometers. So therefore, AD is 44 kilometers. And that is how you find that one. It is a 3-step problem. It is a little bit of work, but it is doable.